Hey everybody, this is Jeff, your CS161B instructor. For those of you that have not had 161A with me, um, or one or 160 with me for that matter, just a quick note on how these video lectures slash demos work. I'm going to demonstrate this material uh, more or less in the order of the textbook, right? So if we go into the textbook here and we look at module 10, for example, I more or less will go through this in order. I don't always, and I don't always say when I kind of skip around, but generally will. And in most cases, the code I show you will be available as a download in the material as well. Um, Kind of depending on, whether I have the links in the video beforehand, right, or not. The like you would see this is week one here. So if we go to content, we're now in week two, and if you go to module 2 overview, you won't see it now because I'm recording the video that goes in here, but you'll usually see in this area the link to the video in any other material that's included. And today it'll be the code, and it will be a couple PowerPoint slides as well. So it'll usually be here, and it will usually also be in the announcement page, so it's easy to find. My recommendation here, as you watch this video, is you don't just passively watch it. Okay. So my approach here is I'm going to demo stuff, and I think you should do what I do. All right. So pause, try it, do the same mistakes even, or different mistakes. It's amazing how much you'll learn. If you try something, you get an error message and you have to debug it. This is really no different than, being an athlete or a musician or an actor or a cook or whatever. You need to practice, and you got to build some muscle memory. Passively watching this will not be enough. And so um, I create a 1 to 2 hour amount of content every week. If you watch this video at normal speed, it's 1 to 2 hours. It's closer to the one side, right? And if you um, pause and try things and do things more than once, that's 2 to 3 times that. You get, maybe close to this in class hour amount here, probably less, right? But that's kind of my logic and how we get to this in class hours here. This muscle memory is super important because C++ has some goofy syntax. I still find that if I'm coding Python and C++ in the same day, I will make silly mistakes because my muscle memory is getting mixed up between, colons and braces and semicolons and things like that, right? And so you need the practice. You need to do the practice for sure. I will be doing the development um, in Replit, which is what I did the most of the development for CS161A. I'll do some stuff in Linux as well because we have a Linux focus in this class. And I may or may not do some things in VS Code. VS Code is really good, and I think it's kind of the new development environment that is recommended here by many. And so the code will generally go back and forth. It used to be a lot harder. I do remember early, 10 years ago, 5 years ago, teaching these classes, and Mac users would have trouble, for example. Nowadays, the Replit code and the Linux code will generally be run together. So if you run into any problems, of course, let me know. So that's what we're going to do. That's kind of the format of these videos for those of you that are new to the class. For those of you that are returning, I got a little bit of feedback to keep doing what I'm doing. There's a couple specific topics that I need to improve for 161A, which I will do, of course, and I welcome feedback at any time here. And so you should always start, like if you go to content, and you go to the module. We're going to do module 2 today, all right? Each of these modules features an individual, a little bit of a mini bio on an individual, and then it's got the different components that we have: discussion, assignment, summary, etc. And then if you click on the overview, that's where you get the learning objectives. And again, in this area is where you'll see the material that we're covering in the video. So with that, let's jump into the content for today. We're going to start to talk about arrays. In a nutshell, an array is a group of elements that are the same data, I should say data type, not data size, same data type that can be accessed and modified using an index. So for example, you might have an array of integers, and each of these, the integers are the, score per student for a test, in a class. Or you might have an array of double values, which are the costs of items in a database. And for those of you that try to make your code handle multiple of the same type of input, you found that without arrays it was really hard to do, right? So we're going to get into this. We're going to start today primarily talking about how arrays work with strings and characters. Okay, and so I have that slide here, but I think it's best if we just jump in. One other thing I do want to mention to those of you that are not used to my videos, I often have my notes and code that I'll retype off to the side on my window. So when you see my attention kind of move to the side or the mouse move to the side, that's what I'm doing here. Hopefully it's not too distracting. Okay, so let's start with introducing the concept of a character array. Okay, and so what we do is we have a character array that looks like this. The 10 indicates the maximum length of the string. The string is one or more characters or zero more characters inside double quotes. Remember that a char itself is in single quotes, but a string is in double quotes. Okay, so we can simply print out like this. So if we run that, we get the string printed like that. Okay, an important constraint: you must declare the char array with enough space to fit whatever values you think you will use. Okay, so in other words, in this example, is 10 characters enough for the dog's name? Maybe it needs to be 15, right? But for this name, 3 or 5 will simply not work. So let's try that, right? If I change that to 3 and I run, let's see what happens. It says the initializer string, right? So this is the initializer string. It's too long to fit. Now let me show you one more thing. Oops. If I make that 5, if we were in person, I'd get a show of hands here to say, you think this will fit or do you think this won't fit? And the answer is it doesn't fit. Okay, well, there's 5 letters in Bosco. Okay, so why doesn't 5 work? Okay, and let me show you why here. Okay, so we can always look at an individual position, right? So if I do this, remember, we always start at 0. My students from last term got tired of that mantra, right? So dog 0, the index of 0 pointing to that array gets me that capital B, right? And so the 1 would get me O, and it's this O, not this O, right? The 2 would get me the S. The 3 would get the C, and the 4 would get the other O. So let's look at what happens when I say 5. So when I get 5, I have nothing here. Nothing got printed here. So let's cast that as an integer and see what's really being printed. I get a 0 there. If I go to my ASCII table and I look at 0, I get a null character. Okay, the null character also tick \0 is always placed at the end of the string. It takes a spot. Okay, so you have to take that into account. Even though when I print the name, you don't see anything extra, right? That null character is required to not print out the things that are past position, the other spots in this array. Okay, so this statement demonstrates showing that array, that null character in the array. Okay, now we could always modify a different, any of the characters. Remember, sorry, I keep hitting the wrong key there. If I do that, let's see what happens. You can see I changed position 0 from a capital B to a capital C. And I can change maybe to something like that. And you can see I can change that too. Now, if I change position 2 instead to the null character, you can see I print up only to that null character. And that's even though I still have a character in a position past that. Okay? And so, important to know that you can modify, you can have data in the array past the null character. When you print the string out, it will stop at the null character. And this allows you to put larger strings and smaller strings and use the same variable here. Okay? You may see different behaviors in different environments here, right? And so let me give another example here. So we will care initialize another array, and in this case we're going to enter. We'll have the user enter. All right. Keep that in. Okay, so we'll enter my other dog's name, and that works. If I enter a longer name, something like that, you can see that it gets truncated to 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. Because remember, I've declared this as 10 and I need a spot for that null character. Okay, so replit is good. It just truncates the data. This may be where you see a difference in behavior depending on your environment. You might see it crash. Worst case, you might see the data overwrite something else. That might be something I show you later on, especially in Linux. If this did not truncate and it wrote the rest of the name in the wrong place, you actually could, it's called a buffer overflow, and you can create basically a security vulnerability, right? So again, something to be very aware of. So question for everybody, why not just use arrays with large values? That would be a way to kind of reduce the chance of problems happening, right? So why would we not do that? The main reason is you are going to consume a lot of memory. And if you only have one variable, it's no big deal, right? And, I'm currently demoing this code on a 32 gigabyte, PC. So I can certainly put a couple, megabytes worth of data in my program without a problem, right? But it's just not good practice, right? And over the course of this class, you're going to learn when you want to use arrays and when you don't, because arrays have this limitation, right? And so they require that you declare the size of the array, and that can't be changed. And so you want to make sure that you pick the right length. In this case, the case of a dog's name, maybe 10's not enough. Maybe 20, right? Or 12 or 15, right? Might be good enough here. Okay. We have demonstrated a little bit of this in 161A, right? But we can walk through the characters to say each position / character in the string. So we're going to start at 0. We are going to loop until the current character, or we're going to, loop while the current character is not the null character, incrementing it by 1 at a time. And we can simply do that. And when I run that, and I type Maisie in there, I get the letters all the way through. Okay, let me add another print statement here. To show that we didn't have that blank character in between, right? Because we're stopping at that null character. Okay, when I run and I do this, if you'll notice what cin does, and I don't remember if we covered this last term or not, cin will stop when you get the first space or carriage return after the first amount of data is entered. So I can put a bunch of spaces in front, but if I do that, for example, I'll just get just that. Okay, that's fine if you are, I'm going to delete stuff I don't need anymore. Remember, the downloaded code you're going to get has all this stuff, right? If you're asking the user for a single phrase that doesn't have spaces, that's fine. But what if we want to be able to handle names? Okay, so I'm going to show you how to be able to handle names. We covered this a little bit last term, but it's good to recap. Like I said, cin will read until data is found and then stop when a new line or space is read in. Okay, that may not be intuitive. The space thing is not, it never was intuitive to me, right? This can be problematic for strings. Okay, so if we create a 50 character array called name, and we'll just demo this again one more time. Get rid of that too. So we enter a name and I say, you know, do that. You see it stops. I could put spaces before and it will skip the spaces, which is maybe, usually, but not always what you expect. Okay, so what we need to do is instead of using cin, we're going to use cin get. And cin get has a different syntax. It tells you the maximum number of characters to go. It will, we're not telling it what to wait for, since we are not giving it it's called the delimiter parameter. It will stop at the new line. New line is when you hit enter, right? So now when we try that, I could put spaces, and I could put spaces after. Let's add a period after here so you can see that. So I put some spaces and I put some spaces at the end, and you can see everything before and after is covered here. Okay, up to that 50 characters. Okay, usually you need, if you're going to keep going, you need to do this, you need to ignore basically the next, got to pull out the new line so we can move forward past. Okay. We can also modify this to pick whatever delimiter we want. And so this will kind of depend, like if you have a database, let's say you have a database of stuff and you always have, a Z at the end. You can see that I read up to the Z and not including the Z because I put the Z there. Okay. So these are different ways for you to work through this. There is a better option as well called get line. So you can do get line like this. Seeing get line is better. It handles the full line. So now I put some spaces like that, and I get exactly the full line. So whatever you decide to use, I use cin a lot. Of course, with numbers, cin is exactly what you want because you're never going to have spaces. With strings, you have to sometimes be more flexible. Okay. Continuing in the material, we can jump back to the book here. What we've covered here is we've covered basically the ability to read the characters from input here. I'm not going to cover 10.3. These are the functions that we covered last term in 161A, the is digit, is alpha, to upper, to lower. Those should sound familiar. We did quite a bit of those. There are a few extra ones in there. If I just bring this up briefly, there's like is space, is blank, is punctuation is a good one, right? And so they all kind of do the same thing, but we're not going to go through those. I feel like we covered them pretty well in the previous class. Recommend that you go through them if you need a refresher. Okay, but let's instead jump to 10.4, which covers copying and appending to strings. Okay, so I've declared a few strings here. They're all 20 characters long. Again, I'm just picking lengths that are working right now. You always need to intelligently pick the lengths that you want here. If I want to copy, I cannot do this. So if I try that, I'm going to get it doesn't let you. You can't do that. Instead, what you can do is you use the string copy command, and the string copy will always, the destination is on the left. So it's the equivalent of saying example equals city. Let me comment that out, otherwise we'll get an error message because I'm not using that variable. And so I get my example there. Okay, if I want to put my city and my team together, I use the string cat command. Cat stands for concatenation, which is a programming term that means to combine two things next to each other. Okay, and so I'm going to say example team. So when I run that, you can see I get the two strings put together. Now that is almost what I want. So before I do that, I need to add I can add a space in there. And since string cat works on strings, even though it's only one character, I have to have double quotes around it. I mean, let's try it with single quotes and see what happens. It's going to complain. Actually, that's empty. It's not what I wanted to show you. Okay, no matching function call, and I get this big, crazy, impossible to read error here. Can be tricky here, right? But we'll change that to a string. And I string catted. I put a space on the end of example, and then I put the team on the end of example, and I got what I wanted. Okay. We learned in the previous class as well the string length function. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Length does not length does not include the null character. It does not. Okay, let's talking about how to compare two strings, right? It would be nice if you could say, let's reassign. We can't say this. That doesn't work on strings. Okay, array comparisons always evaluate to false. Okay, so this is a nuance in how array data is referenced and used by the code. We're actually not comparing the data in the arrays in this case. We're comparing where they are in memory, and so they will always, if you're comparing two things, they'll always be different. Okay, so we have to use a different function. So this doesn't work. So instead, we use string comp or string compare. And string compare is a goofy function. If it evaluates to 0, oh, I forgot, I took it out. We can get rid of all of this. So they match. Okay, so if the string comp gives you a 0, then they match. So let me show you what happens if they don't match. I'm just gonna print out the comparison value. Okay, so I got a positive number. Okay, if I swap city 1 and city 2, I get a negative. No, well, yeah, let's just do that. Sorry, let's just do that. I get a negative number. So you get a negative number or a positive number if they don't match. Now, you could play with the data, and now I got a 3 instead of a 1. Why is that, right? So you cannot rely, so string comp will return 0 if the two strings match. Will return a positive or negative number if not, and you cannot rely on the value of the number. Like, it would be helpful, right, for this to give me a value of 2 because it's the, or 1, right, because it's the index of 1 where the first mismatch is. But it doesn't do that. Instead, it gave me 3. And I can't explain that. It all depends on the implementation here. Okay. One more example here of playing with these character arrays here. We might have had a palindrome example in 161, I think. I think we did. For those of you that don't know what it is, a palindrome is a pattern that reads the same right or left. Okay, so I think like the most famous one is race car, right? If you look at race car, it reads the same. It reads the same right or left, right? There's another one, right? Those are, I think that those are kind of the most well-known ones, right? So let's try it. I'm gonna create a character array called pattern. Okay, we're gonna claim no spaces here because I'm just gonna use CN for simplicity's sake. Okay, the way I'm gonna do this here is I'm going to declare an index called L, which will be the left side of my pattern, and an index called R, which is going to be the position of the rightmost character. And remember, since string length gives the length and we start at 0, I have to subtract 1. I'm going to set a flag called pal. I'm going to set that equal to true. And I'm going to say, well, as long as left is less than right, I'm going to compare the character at the left index with the character at the right index. If they are different, I'm going to set pal equal to false. I'm going to break out of the loop. Otherwise, I'm going to add 1 to L and subtract 1 to R. So I'm gonna kind of march from the ends in, comparing until I find one that doesn't work. And I'll just print my result kind of. I'll build the sentence here. And so I'll say the pattern is a palindrome, but if it's not, I'll put the word not in the middle, right? So it's just as easy, right? It is totally just as easy to do it this way. You totally could do you could do it either way, right? And so I'll keep both in to demonstrate that. Okay, so this is a matter of preference. This bottom one is me being tricky to avoid duplicating code, right? If I'm trying to do a complex print statement and the only thing different is one word, then I'm going to do something like this. But if I'm just printing a sentence like this, honestly, this is the better choice, all right? So we can do taco cat, and that should work. We can do 1, 2, 3, 2, 1, and that should work. That should work. And even that should work, right? So we're processing through the characters here, regardless of the length of the string. And the reason I demonstrated this function, this function here, is now I want to put it inside a function, and I want to show you how you pass arrays to functions. Okay, so this is the same code. I'm going to explain that in a minute, right? You're probably noticing something that's a little different there. I am going to take the code. I'm going to paste it in here. And then I'm going to return my Boolean because I've declared my function as a Boolean function, right? Okay, we'll keep the enter, the palette, we'll keep that the same. And we're going to say, well, here we won't bother doing input here. We'll just say char pat1 equal array star char pat2 that might be more than 30. We'll just do that. And what we'll do is we will say, well, let's just do this one at a time. If is palindrome pat1 since we're looking at the code, we'll be we won't bother trying. We won't print out the same stuff. We're just doing this fast here. Pat2, yes 2, pat3, yes 3. My sample code has got it's a little bit more self-documenting, but let's give this a shot. Okay, so this didn't work because I forgot an E right there. Okay, the triple taco cat is too long. Taco cat is 7, so that's 21, 22, 23. So let's make that 24. And so yes 1 and yes 2 returned, yes 3 did not, right? Which makes sense. Okay, let's look at what I did here. Okay, I declared arrays that were 3 different values, 3 different lengths, 10, 24, and 40. Inside here, I did not say what the size of my pattern is. So in other words, this is palindrome. Will work on any size string array that's passed to it, whether it's 1 or 1,000 or 1,000,000. Okay, I want to show you one more thing, which is if I take my pattern and I append to it, make these bigger just to be safe. Let's watch what happens. Oh, I need to print them. Too fast. So if you look here and see what happened, I added exclamation marks to my strings. Okay, so in all three cases. So this is effectively passing by reference. Okay, you cannot pass an array by value. You can only pass it by reference. And we'll get into the details about this later in this class because of the way that arrays are structured in memory and how they're accessed using a technique that are called pointers. Some of you may have some familiarity with that. We get esoteric here and it gets confusing. But for now, think about that when you're passing arrays, they can only be passed by reference. And you don't need, because you're passing them by reference, you're passing the location where that array is. You don't need to pass the size because the length command will find the size for you, right? And so that's why you don't need a number here. And if you place a number there, you'll run into trouble, right? Okay. Last thing, well, I think, yeah, this is like the last thing I want to walk through here. I feel like this is going relatively quick today, but this is a lot of review still because the string stuff we've covered. I want to talk about the concept of a two-dimensional array. Okay, so a two-dimensional array is just rows and columns, right? This can be really powerful. This can be some good stuff here. We will dive into this more in the next couple weeks here. But I want to walk through 10.8 as a quick example here. If I jump back to the book here, let's go back and look at the. So we talked about functions, right? And inside 10.8, there's a, let's see, yeah, we're going to talk about doing kind of a two-dimensional or a list here. So let me walk through an example of that here. So I'm going to declare a 3-row grid, if you will, of strings that are each up to 50 characters long. 49, remember we include the null pointer. Okay, so I picked foods. And I'm going to use getLine in this case so that you can put spaces in your foods if you want. Normally, these numbers are best used as constants, right? And so you're going to have like max favorite lengths or number of favorites. I generally don't want to see uh, for lengths of strings for you to hard code numbers in them, because if you have that number in multiple places, and if you decide to make your strings longer, you got to change them in multiple places. And if you're using multiple different lengths and different strings, you can't use global searches and replaces. And global search and replace is dangerous anyway because you might be changing other things. So you want to do something to the effect of um, something like that, right? Okay, I think I did that right. We'll see. Okay, so now we will print out okay, we don't need the palindrome anymore. Let's go ahead and run that. So I'll say and so there you go. Okay. And so again, you can have this instead of being 3, you can have it be more. You could set your max number of favorites to say 100, and you can ask the user to say how many favorites do you want to enter, or enter your next favorite, enter queue to quit, and you'll only keep a certain amount, right? Similar to what we did in some of the assignments later on. But this is how you create this is what's called a two-dimensional array here. Okay, now let me show you how you will use a nested loop. This is just getting into the next level of detail. When you're doing a two-dimensional loop, you're going to like go per row, and as you go per row, you're going to go per column, or vice versa. We're not doing that here because this just processes the whole row at once. But let's say we want to do something a little different. We're going to count the occurrences of the letter A in our string. And I just realized how I'm doing this is a bad idea, but I'll show you that in a second. Some of you should be looking at my code thinking, okay, what is wrong with this loop here? All right, so let's try this again. We're at a semicolon. Okay, let's go ahead and run j equals 0, j plus plus. Okay. Okay, so it caught an A there and an A there. Okay, so you could see this is how I basically indexed every character in the grid, row and columns grid. Now what I did wrong here was I just went from 0 to 49 for each row in the in my array. Given that I hit the null character and nothing after that is a letter A, it turned out that I'm okay here. But really what you want to do instead is you want to say, you want to do this. So in other words, and I showed you this earlier when I did the first example. I basically am going to say, starting at 0, until I hit the null, I'm going to increment. This is better for two reasons. One, it won't catch A's that are in the data that are not actually in your strings. which would give you the wrong values. That's the real problem. The secondary problem is if my favorite length was thousands and I had thousands of entries, I'm going to be doing a lot of extra processing here that I wouldn't need to do, right? Because I'm just going to do only the characters here. So if I have like something like that, I'm going to get my 1, 2, 3, 4, 5. And I'm not going to basically try to keep going throughout all the way up to 50, right? In characters that are not relevant. Okay. So this is a little bit about, two-dimensional arrays. We'll do some fun stuff in the next couple classes where maybe we'll do a word search or we'll do something like that to kind of give you a the ability to kind of see how you can navigate these two-dimensional arrays, which can be pretty handy. But that's it for today. As always, run through the examples, please. Um, Nobody's keeping time except you. It's okay to pause and restart and pause and try things. Questions, comments, let me know, and we'll talk soon.